Welcome and thank you so much for joining me. We are going to be working on the Hamiltonian path and cycles. Now, unlike the Eulerian, we are thinking about the vertices, which the Hamiltonian focuses on going through every single vertex. So, in the first one, we are starting off at A and going to B, to D, and to C. In this case, we call this a Hamiltonian path because it's only going through every single vertex once, and the start and finish points is not the same. The second part is we are going to be looking at a Hamiltonian cycle. And this is the start and end point is the same, but it only goes through each vertex once. So we've got A to C, to F, to E, to D, to B, and to A. So our start and end point is exact same. Let's look at some examples. When we are looking at a Hamiltonian path, the best thing to do is draw out the path and then we can list it. So sometimes it's about trial and error, so it's good to be using a pencil. Okay, so now I've got my path here, I am able to write it. And again, we've got a different start and end point, so it's a path, not a cycle. So we're going A to F, to G, to B, to C, to D, to E, and to H. Okay, likewise with our first question over here, I'm just going to start off at any point. So remember, we need to go through every single vertex. So it doesn't matter what point I pick here, because I can just go around the outside, and I have gone to every single point, and I get back to the same point. So if I'm starting at A, I'm then going to B, to C, to D, to E, to F, and back to A. So in this case here, it is a Hamiltonian cycle. Now, exactly the same thing is occurring on my next network. Same thing in a sense that I need to think about how am I going to go to every single one and end back at the start. So I'm going to start at A to F, then go F to E, E to D, D to C, C to B, B to G, and G back to A. And there is our cycle. We're only going to each vertex once, except at the start and the end. So we write that by going A to F, to E, to D, to C, to B, to G, and back to A. Let's look at a worded question. And these worded questions, we really need to make sure that we are breaking the question down. So this first part says, the graph opposite models the pathways linking 7 animal enclosures in a zoo to the kiosk and to each other. Is it possible for a visitor to the zoo to start their visit at the kiosk and to see all of the animals without visiting any one animal enclosure more than once? If so, identify a possible route and give this route its mathematical name. Okay, so we're starting at the kiosk. So we want to see all the animals only once. So this is where we need to just draw out our map on our network. In this case here, I have come up with a pathway. I'm starting at K, and I'm going to G, to D, to E, to S, to L, to T, to M. I could make it back to the kiosk. Because I've made it back to the kiosk, that means we are going to be calling it its Hamiltonian cycle. Because remember, a cycle has the same starting and end point. I'm going to change color for our second part of the question. Is it possible for a visitor to the zoo to start their visit at the deer and finish at the kiosk? So we're having different starting and end points. So the first thing I'm going to do is mark my deer and mark my kiosk. Then I'm going to look at a pathway through. To start off with, I'll go from deer to the G. Then I'll go to E, elephants. Then I'll go to the seals, the lions, the tigers, the monkeys, and I will finish in the kiosk. Now, in this case, we are able to do it. So I'm just going to write that out. And that is D to G to E to S to L to T to M to K. We call this Hamiltonian path. And it's a path because the start and end points are different.